Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got the 3D isometric projection of a solid in which the front face, the top face and the right hand side face, they have been clubbed into a single 3D isometric projection. Now we are required to convert this isometric projection of the object into the three orthographic projections. So we are required to draw the front view, the top view and the right hand side view projections of the solid. Now in order to obtain the orthographic projections, we need to evaluate the dimensions of the front view face, top view face and the side view face over there. Now when we are going to look at the solid from the front side, so we observe that the width of the solid, it happens to be 100 millimeter and the height of the solid, it is equal to 70 millimeter. So the front view face will be having the dimensions 100 millimeter by 70 millimeter. Now when we look at the solid from the top side, then we observe that the width of the solid, it is equal to 100 millimeter and besides width we require the depth of the solid. So the depth of the solid, it is equal to 70 millimeter, right? So we have got the top view face dimensions as 100 millimeter by 70 millimeter. Now looking at the solid from the side view, so we observe that the depth of the solid, it is equal to 70 millimeter and the height of the solid, it also happens to be 70 millimeter. So we have got the side view face will be represented as a square having edge equal to 70 millimeter. Now let us evaluate that whenever we are going to look at the solid from the front view, top view and the right hand side view, what are the surfaces which will be available with us. Now when we look at the solid from the front view, that is from the front side, so we are going to observe three surfaces over here. Surface number one, it will be this surface, that is it will be L-shaped surface. Then the second surface, it is the rectangular surface having width is equal to 25 millimeter and the height, it is equal to 15 millimeter. And we have the surface number 3 over here. This surface is also having a width of 25 millimeter and the height equal to 15 millimeter. And all these three surfaces, surface 1, surface 2 and the surface 3, so they are all parallel to the vertical plane. So in the vertical plane, in the front view, we are going to observe true shapes of these three surfaces. And besides these three surfaces, we have got another surface over here which is lying on the back side of this web over here, right? So this web corresponding to the surface 1, so this is going to overlap the surface. So that is why we haven't shown this surface as a separate surface. And corresponding to the circular portion, if we are going to look at this web from the front view, so we are going to get a dotted line over here, that is as a hidden line over here corresponding to this portion of the circular section which is visible to us from the right hand side view. When we are going to look at the solid from the right hand side, so we are going to observe these three surfaces over here, that is surface X, surface Y and this is surface Z which is corresponding to this rectangular slot. So this surface Z will be covered by this surface X over here. Now when we look at this surface X from the right hand side view, we observe that it is a rectangular surface which happens to be parallel to the profile plane. So the projection of surface X will be obtained as true shape onto the profile plane. Similarly, the surface Y which is appearing at the back side corresponding to the vertical web of the solid. So this surface, it is also parallel to the profile plane and the projections of surface Y on the profile plane will be appearing as the true shape of the surface. and this is surface Z, which is corresponding to the rectangular slot which is available over here, and this surface Z, it will be covered by surface X. So that is why corresponding to this edge which is available at a depth of 15 millimeter from the front face, we are going to obtain a dotted line corresponding to this surface 2 over here, so which is perpendicular to the surface X over here, right? So these are the projections we are going to observe from the right hand side view. Now looking at the solid from the top, so we find that we are going to observe surfaces P, Q, R and S from the top view. So surfaces P, R and S, they happen to be parallel to the horizontal plane. So the projections of the surfaces P, R and S onto the horizontal plane will be viewed as true shapes of these surfaces. Whereas we have another surface, surface Q. So surface Q, it is a curved surface. So since it is a curved surface, we are not going to obtain the true shape of this curved surface Q onto the horizontal plane. So this surface Q will be represented as a rectangle in the top view, so which will be the apparent shape of the surface Q. Now let us start with evaluation of the orthographic projections of the solid. So step 1, we are required to draw the XY reference line and the X1 Y1 reference line, and since we have to draw the front view, top view and the right hand side view projections of the solid, now the front view will be drawn above the XY reference line, top view will be constructed below the XY reference line, and the right hand side view of the solid will be projected on the left hand side of the front view. Now let us draw the front view first of all. So we know that the front view face, it will be measuring 100 millimeter by 70 millimeter. Now we have to draw the width of the solid which is equal to 100 millimeter. So this is equal to 100 millimeter width which we have drawn in the front view, and this width dimensions, they have been projected onto the top view also, because in the top view we are going to require the width of the solid as one of the dimensions over there. Now here we have marked the height of the solid which is equal to 70 millimeter, and this projection line corresponding to the height of the solid equal to 70 millimeter, this has been extended onto the right hand side view, because in the right hand side view we will be requiring the height of the solid equal to 70 millimeter. Now let us plot the depth of the solid. Now the depth of the solid, we know this is equal to 70 millimeter. So this is the depth of the solid equal to 70 millimeter. So we have marked this depth equal to 70 millimeter, and this depth of the solid from the top view, now it will be projected onto the right hand side view using this transfer line. So using this transfer line, so we have shifted or transmitted this particular depth of the solid onto the right hand side view. So it is only for the purpose of understanding we have added these dimensions. Otherwise these dimensions, they were already mentioned in the front view as well as in the top view, but later on we are going to remove these dimensions from the final orthographic projections of the solid. Now since we have obtained the front view face, top view face and the right hand side view face, now we will be starting with construction of the front view projections of the solid. Now looking at the solid from the front, so we obtain that there are two webs which will be visible to us. This is the horizontal web and this is the vertical web. Now let us start with the horizontal web over here. So in the horizontal web we observe that the height of this horizontal portion or the horizontal web of the solid, it is equal to 15 millimeter. So we have drawn a projection line corresponding to the top surface of this web, that is surface S over here, right? So corresponding to the top surface of the horizontal web, we have drawn a projection line which will be extending onto the right hand side view as well. Now next, when we look at this particular solid from the front view, we observe that there is a vertical web also. It is having the width equal to 15 millimeter. Now let us mark this width of the vertical web in the front view. So we have marked this width of the vertical web as 15 millimeter and then constructed a projection line so that we are going to extend this projection in the top view as well. Now this web vertical one and this is the horizontal component of the web over here. Now next thing is we observe that in the horizontal web from the right hand corner as we move along 25 millimeter towards the left side, so there is a rectangular slot which has been provided over here, and the dimensions of the rectangular slot, they are, you have width is equal to 25 millimeter and the depth of this rectangular slot happens to be 15 millimeter, so that this total 100 millimeter, so we have divided it into three parts. 25 millimeter will be the width of the surface number 3, 25 millimeter will be the width of the surface number 2, and 50 millimeter will be the width corresponding to surface which has been marked as surface 1. So corresponding to this, we have marked 25 millimeter distances from the right hand corner of this particular solid, so that we can get the projections corresponding to this edge and this edge over here, right? So now having obtained these dimensions, we need to have one more dimension over here, that is regarding the center point of this particular circular portion of the vertical web over here. So the vertical web, it is not going straight. Again there is a slot in which 20 millimeter, it is the vertical portion, this 20 millimeter, and 35 millimeter, it is the height of the center from the top face of the surface S over here. Now 15 millimeter was the height of the horizontal web, 35 millimeter, it is the height of the center point from the top surface of the horizontal web. So we had drawn the top surface of the horizontal web over here. Now we are going to mark 35 millimeter above this top surface of the horizontal web, that is 35 millimeter above the surface S over here. So this distance we have marked so that we can obtain the center of this particular circular portion in the front view over here. So once we mark this center, so we automatically get the vertical, this particular, you see, vertical portion of this slot over here on the vertical wall. So this vertical section will be equal to 20 millimeter. So once again, total dimension we had marked as 70. So 15 mm, it corresponds to the horizontal web. 35 millimeter, it corresponds to the center of the circular portion. And the remaining 20 millimeter, it is the vertical length of this particular slot. Now the next thing we want to do is, please check, this radius, it is equal to 20 millimeter over here, because from this center we have got a circular portion of this particular slot over here, which is measuring diameter is equal to 40 millimeter, or radius of this arc or the circular portion will happen to be 20 millimeter. So I have obtained the bottom point, that is this base point of this arc I have been able to obtain by constructing another projection line which is at a distance of 20 millimeter from this center line, right? So why I have drawn this particular horizontal line over here or the projection line over here? The reason is because when I am going to look at this particular, you see, slot over here from the front view, I will be obtaining a hidden line or a dotted line over here corresponding to this portion, that is this portion of the slot. So I could have drawn the dotted line right straight away over here, but I will be projecting this dotted line once I complete the side view over here, because that will give me a better understanding of the U-shaped slot which is obtained on the right hand side, and only then I will be drawing the hidden line over here. But just for your reference, that we have marked that this distance of 20 millimeter is there from this center point, that is starting from this center, the radius of this circular portion happens to be 20 millimeter. Now let us start darkening all the edges, because all the elements of the front view, they have been completed. So let us start with the vertical wave. In the vertical wave, so this portion, it is visible to me, so that's why I have darkened this portion of the vertical wave. And regarding the horizontal portion, I know that I have to draw this straight, and then these two vertical edges I need to draw corresponding to this vertical edge and corresponding to this vertical edge, so that I get the size of the surface number 3, it equal to 25 millimeter width and 15 millimeter height over there. So this is 25 millimeter width and 15 millimeter height. Similarly, the size of the surface which has been marked as surface 2, this is again width is equal to 25 and height is equal to 15, right? Next, I could have drawn, as I told you, a dotted line over here, but I'll be drawing it later on once I complete the side view. Otherwise, the projections of the surfaces which are visible to me, they have been completed. Now I am going to mark these surfaces. So this is my surface number 1. This is L-shaped surface over here. So this is the L-shaped projection which I have obtained in the front view. So this is rectangular projection corresponding to surface 2. This is rectangular projection corresponding to surface 3, which has been obtained. So only one thing is missing, that is dotted line corresponding to this portion of the web over here, right? So this vertical web slot, this portion I am going to complete later on. So let me complete the top view of this particular solid. In order to draw the top view of this particular solid, I know that this is the total depth of the solid, right? The total depth of the solid happens to be 70 millimeter. So out of the 70 millimeter, I have got the depth of the surface R, it is equal to 15 millimeter. Depth of the surface P, it happens to be 15 millimeter. So this is 15, this is also 15, and the remainder portion will be 40 millimeter. So that is why if this remainder portion is 40, so this diameter of the arc will be 40 and the radius corresponding to 20 millimeter I can draw from this particular center. So now in order to draw this portion of the web over here along the depth, so I have drawn a projection line at a distance of 15 millimeter from this surface over here. So please check, the 15 millimeter depth has been drawn from this surface, that is from the rear surface of this particular solid. Similarly, from the front side also, this is my front side. So from the front side, again I will be looking at a depth of 15 millimeter, right? So from the front side, as we move towards the rear side, so there is a depth of 15 millimeter corresponding to which another projection line has been drawn over here. Now these two webs point, that is P and R surfaces, I am able to locate. So this is my surface R, you can check. This is my surface R, which is a square having a cross section of 15 millimeter, and this is my surface P, which is again a square having the edge equal to 15 millimeter, and this remainder, this is my top view, right? So this is the top view of this circular cross section. And what are the dimensions? Dimensions are, that is, you have the width equal to 15 millimeter and the depth equal to 40 millimeter. So this is the width equal to 15 millimeter and this is the depth equal to 40 millimeter. So I have obtained surfaces P, Q and R over here. Right now I have also got the location of the slot. So all the, you see, edges, they have been marked over here in the top view. Now I am going to start with darkening of the edges which are visible to the observer when the observer is going to look at the solid from the top side or the above. Now this edge, it is visible to the observer. We can see this edge, it is visible to the observer as a straight line. So we have darkened this. Then this edge, that is this portion, and this portion, they will be appearing to the observer as a straight line, as the observer is going to view the solid from the top. So this is again a darkened line. Then corresponding to this edge, again the observer is going to obtain the darkened edge over here. And now I have to obtain the top view of this front edge. So from the front side, the observer will be checking that you need to move 25 millimeter towards the left, and then there is a rectangular slot which is measuring 15 millimeter depth and 25 millimeter width over there. So that now I can move 25 millimeter back. Now you have the depth equal to 15 millimeter, and then the width of the slot is equal to 25 millimeter once again. And this gives me the top view outer projection over here. Now let me draw this particular wall of this vertical web over here. So I can darken this. This vertical web will be available to me as a straight line. And finally, I will be drawing the horizontal lines over here corresponding to the edges, this one and this one. Now this completes the construction of the top view. Now this is my surfaces, that is surface P over here. This is my surface Q. I told you that surface Q will be appearing like a rectangle in the top view. So this is the apparent shape of the surface Q, whereas surface P, surface R and surface S, all these three surfaces, they happen to be true shapes in the top view. Now let us draw the side view over there. In order to draw the right hand side view, so two things we can observe, that is you can see this portion is visible, this portion is visible, slot over here in the vertical web. So the vertical wall, it is visible. Yes, please check this portion and this portion, they will appear as a straight line in the side view. Similarly, this portion and this portion, they will be appearing as a vertical edge in the side view. Then corresponding to surface P, you are going to get the depth equal to 15 millimeter. Corresponding to surface R, again a depth equal to 15 millimeter will be drawn. And then there are two vertical edges which will be moving down 20 millimeter from surface P and 20 millimeter down from the surface R over here. Right, so from both of these surfaces P and R, you move 20 millimeter down. So this is 20 millimeter distance which we had marked earlier in the front view. Now we have obtained this center point. So this is the center point of this circular arc. So once we have obtained the center point of the circular arc, now I can draw this radius of 20 millimeter over here. So this circular portion of the arc, now this is visible to me in the right hand side view. Now the radius I have marked over here equal to 20, and the moment, you see, the moment I obtain this particular circular arc, now corresponding to this, I can draw a hidden line over here, because from the front view, this curvature over here, so corresponding to the front view, this curvature will be appearing like a hidden line in the front view. So this is the hidden line. Now with this construction of the hidden line, my front view is also completed in all respects. Now let us draw this portion of the side view. So in the side view, surface X, it is visible to the observer. So I can draw the surface X over here. So the complete surface happens to be surface X, whereas there is another surface Z which lies behind the surface X over here. So this is surface Z which will be overshadowed or covered by surface X. But this surface Z is special because in this surface there is surface 2 over here. Please check, in this object there is surface 2 which happens to be perpendicular to the surface X, and corresponding to this surface 2 I am going to get a dotted line or a hidden line corresponding to the surface 2 over here. So this hidden line I have drawn. So this is my surface Z, this portion which has been covered by surface X. Surface X is the complete rectangle which is visible to me in the front view, and these are the projections of the surface Y. So with this we have completed the discussion about evaluation of front view, top view and the right hand side view of this particular solid when the isometric projections they were given to us. Now let me remove the faces which were marked in the three views so that we can have the better interpretation of the results of the orthographic projections, and we can have the better correlation between this isometric projection and the orthographic projections which have been obtained. And finally, these redundant dimensions or the extra dimensions which we had shown initially just to improve the visualization of the construction of the orthographic projection. Now these extra dimensions or the redundant dimensions, they have been removed. So this is the final orthographic projections of the solid, right? So this is all for today. So we'll be continuing with few more cases on the orthographic projections in the coming lectures. So thank you very much. Thanks a lot.